AP Calculus, ABBC, Exam Review, Differential Calculus Fundamentals, Question 8, Comparing Features of Functions, Minimum Values. So f is a function defined on all real numbers. And just in case you're wondering what a real number is, I'll give you a concrete definition and some examples. So real numbers are the numbers that we typically use, such as 1, 15.8, negative 0.1, 3/4. They're numbers that are negative, positive, large or small, whole numbers, or even decimal numbers. And they're called real numbers because they're not imaginary. Imaginary numbers are of the type I, which is defined as the square root of -1. So anything that has some multiple of I is an imaginary number, okay? So the imaginary number is the only type that's not real. G is a function defined on all integers between -3 and 3 inclusive. And just in case you're wondering what integers are, they're whole numbers that are not decimals and fractions. All right, so they're numbers like 3, -1, 0, 2. So those are pretty much, examples that we can come up with that are used here. All right, and one more note. An inclusive range in numbers includes the first and last number and all the numbers in between. Okay, so from -3 and every integer you see here, all the way up to 3. And another way of expressing an inclusive range is as such. -3 is less than or equal to x, which is less than or equal to 3. Notice the less than or equal to signs. The equal to portion is what makes up the inclusive range. Okay? And finally, h is a function defined on all real numbers. Its graph is shown below. And again, for those of you who need constant refreshers as to what's categorized as a real numbers are the type of numbers we normally use, such as 1, 15.8, -0.1, fractions like 3/4, and note this is a decimal, a negative decimal at that. All right, so real numbers can be positive or negative, large or small, whole numbers or decimal numbers, and fractions. These are all categories of real numbers. They are called real numbers because they are real and not imaginary. Imaginary numbers are of the type I, which is defined as the square root of -1. This is not a real number, okay? The minimum value of which function is the lowest? Is it f of x, or the minimum value of g of x, or is it the minimum value of h of x? It's easiest to find the maximum or minimum of a quadratic if it's in vertex form. Right now, function f, or f of x, is in what we would call polynomial form. We can transform the presentation of this quadratic into vertex form by doing a technique that's called completing the square. It's kind of like reverse FOIL method, FOIL, when you do the first term, the last outside term, inside term, and last term. Well, it's the reverse of that, okay? So here goes. I'm going to show you first what vertex form looks like. So we have y, or if you want, you could pretend that this says f of x. is equivalent to A, and A tells us whether the parabola is concave up or concave down. So if A is negative, the parabola is concave down. But if A is positive, the parabola is right side up or concave up, okay? We're going to multiply A times x minus h. But before moving on and presenting this form, it's important to note that h is the x value, where a line through that x value, a vertical line, is basically the line of symmetry through the parabola, okay? It perfectly splits the parabola in half. So pretend those are two lines of symmetry, although they're not quite symmetrical, linear objects. All right, so that's what h does. And again, we're multiplying A times x minus h, but we're also squaring the x minus h term. This is where we get our parabola or a second degree equation plus k. And the important thing to note about h and k is that h and k represent the x and y coordinates of where the vertex occurs, okay? So this is what vertex form looks like, all right? And I just want you to note one more thing. Since this parabola that we're dealing with in this particular problem has a leading a term that's going to be positive, it's basically a right side up parabola. Therefore, we have a minimum value rather than a maximum value. And we would have a maximum if the parabola had a negative in front of the x or a negative a term, and there would be a maximum value where the vertex occurs, but we're dealing again with a minimum value here, okay? All right, so let's complete the square. We're already told that f of x is equivalent to x squared minus 2x plus 2, okay? So now here goes our attempt at completing the square. And remember, we're completing the square in order to reach a vertex form presentation of this particular quadratic or a second degree equation or equation of a parabola. All synonymous terms, okay? So first of all, we know that we're told x squared minus 2x. Well, this looks like the beginning formation of the difference between two squares. And in order to get a perfect square or complete the square, what number, when you add it together, you get 2, negative 2 at least. So what and what will give you negative 2? Well, that's going to be negative 1. So now we have to figure out what the product of negative 1 is. It's like we're doing a reverse FOIL method. So completing the square is literally doing a reverse FOIL method, okay? So of course, negative 1 times negative 1 gives you positive 1. And negative 1 plus negative 1 gives you the b term in polynomial form, which is going to be negative 2 in this case, okay? So now to keep things algebraically legit, if we add positive 1 here, in order to undo that, we're going to have to also subtract 1, okay? And notice that in our original equation, we had a plus 2. We can't just get rid of it, so we have to maintain that. And we can still do this and complete the square. I'm going to show you how. So, remember I just told you completing the square is kind of a reverse FOIL method. So we have to encapsulate the first 3 terms of this polynomial form in parentheses, okay? So that's done, and we still have to maintain our negative 1 and positive 2 or minus 1 plus 2, however you think of it in your head. All right? So now let's start to basically complete the square and form our vertex form. What we can first do is combine these two terms. So negative 1 plus 2 is going to yield a positive 1. So this is our k value, or the y value of our vertex. And remember, since the leading term is positive, this is a concave up or right side up parabola. So it's going to have a minimum value at the vertex rather than a maximum value, okay? So now we have to reduce this into a times x minus h form, and that's going to be basically 1. You don't need to write the 1 here, but I'm just doing it for understanding. X minus 1. So our h term is going to be 1, and our k term is 1. So the vertex occurs at 1, 1, and this is going to be a minimum value because it's a right side up parabola. And notice that the x is inside the square. So anything that's squared can either only be 0 or a positive. And so out of those two options, 0 would be our lowest value. And the 0 or minimum value occurs when x is in fact equivalent to 1. So our relative minimum occurs at 1, okay? And the value yielded is going to also be 1. So basically 1, 1. Or the x value is 1 and the y value is 1. That is going to be our minimum, okay? A visual inspection of the table reveals that the minimum value of g occurs when x is negative 1. But the actual magnitude of the minimum output is 2. Therefore, the minimum y value or the minimum g of x value is going to be 2. Okay? From the graph, we can see that the minimum value of h occurs when x is negative 3, and the value yielded or the output is also going to be negative 3. Okay? Of the functions we examine, h of x has the lowest minimum value at y equals negative 3 or h of x equals negative 3. Therefore, h of x is our answer. Okay?